10 days ago, the newest images of 3I Atlas appeared and immediately created a scene that felt both familiar and impossible. The object looked like a comet, yet its strange plasma glow and the stream of gas pushing toward the sun did not resemble anything ever observed in our solar system. These unusual features sent viewers into a wave of confusion as the real discovery was buried under rumors and edited images. This video will show you what the verified data actually reveals. Still, a larger question remains at the center of everything. 3I Atlas is changing in ways no one expected, and we must ask what it is becoming next. "3I Atlas entered our view on November 17th, and the first measurements showed that it was moving with a speed that did not match anything we normally see in our solar system. Scientists quickly realized that this object came from interstellar space because its path did not follow the pattern of comets that form inside the distant Oort cloud. The Oort cloud is a huge shell of icy bodies that surrounds the solar system, and most long-period comets come from that region after being pushed by passing stars or strong gravitational tides. 3I Atlas did not follow that history, and its path pointed back to a place far beyond the reach of the sun's influence. This detail made the discovery feel almost unreal, because objects from outside our system rarely pass close enough for us to study them in real time. When astronomers calculated its velocity, they found a number that caused even more attention. The object traveled at nearly 58 kilometers per second when it first appeared, and that speed later increased as it moved toward the sun. Most comets accelerate near the sun because sunlight heats their icy surface. But 3I Atlas showed this behavior earlier than expected. The change happened fast, and the numbers reached almost 68 kilometers per second near its closest approach. This value placed it among the fastest natural objects ever observed inside the inner solar system. The high speed made tracking difficult during the first hours because small errors in measurement created large differences in predicted positions. Astronomers had to combine observations from multiple sites to narrow down the exact path, and each update made the picture clearer. Even with the early challenges, one detail stood out. The object moved smoothly along a stable trajectory without any clear sign of sudden turns or violent motion. Interstellar objects sometimes behave unpredictably because they carry different materials or spin in unusual ways. But 3I Atlas stayed steady while crossing the inner regions. This stability allowed scientists to rule out many early fears and help them focus on the physical traits that made the object unusual. The shape of the orbit also supported the idea that it had traveled for millions of years across deep space before entering the sun's gravity. The long journey meant that it had survived collisions, radiation, and extreme cold, which added even more mystery to its sudden appearance. The first images of 3I Atlas created confusion because the object did not look like anything people expected to see only hours after its discovery. Astronomers captured early frames and saw the bright coma surrounding the object surprised many viewers because it leaned toward the sun instead of flowing away from it. Most comets develop a coma that grows in the opposite direction of sunlight. Yet 3I Atlas showed the opposite behavior in the first photographs. This strange orientation forced researchers to check their equipment and repeat their observations to make sure nothing had been misaligned. The unusual shape did not come from a single telescope, and that made the discovery even more interesting. Multiple observers from different countries reported that the coma appeared dense and seemed to push toward the solar direction. This detail suggested that the object reacted to sunlight in a way that did not fully match the behavior of comets inside the solar system. Some astronomers believed that the object might be shedding material unevenly, which could create a temporary effect that pushed the coma forward. Others suggested that the angle between Earth, the Sun, and 3I Atlas distorted the view, causing the coma to look misplaced. Long exposure photographs added another layer of confusion because light streaks, camera shake, and atmospheric blur created artifacts around the object. These artifacts made the coma appear stretched or twisted, and this visual noise encouraged online speculation. As more people shared images, the differences between them sparked debates about whether the object had multiple tails or only one. Some photos showed a faint streak behind the object, while others seemed to show no tail at all. This inconsistency did not point to a dramatic change in the object, but instead reflected the different methods used by amateur astronomers. People unfamiliar with astrophotography often trusted the most dramatic images, even if they included distortions or exaggerated features. Professional astronomers had to spend time explaining that early images can appear unstable because the object is still heating up as it moves toward the inner solar system. As the object approached the Sun, more jets of gas and dust were expected to appear naturally, and this process would slowly shape a clearer tail. The early confusion reminded people that first impressions in astronomy can be misleading when the object is still undergoing fast changes. This raised a new question that many viewers wanted answered. If the first images looked this strange, what would happen once the object moved closer to the Sun and began releasing even more material? The days following the discovery showed that 3I Atlas was entering a new stage, and the object began to release more material as sunlight reached its surface. Astronomers noticed that the coma became brighter and more active as the object moved deeper into the inner solar system. This reaction suggested that ice within the surface layers was rapidly turning into gas, which is a common process for comets that approach the Sun. However, 3I Atlas displayed this change sooner and more intensely than many observers expected. Jets of gas started to appear in long exposure photographs, and these jets pushed dust into surrounding space, forming the early structure of a tail. The tail itself looked uneven at first because it formed under strong heat while the object was still spinning. Some regions heated faster than others, creating short bursts of gas that flashed across several images. Each new observation helped scientists understand how much energy the object was absorbing during this period. In interstellar space, an object like 3I Atlas receives very little solar energy, but after entering our system, it experienced a dramatic jump in heat. This sudden rise changed the chemical behavior of its surface and caused the release of dust, gas, and ions. The combination of these components created a plasma-rich environment that grew more obvious in every new photograph. Researchers noted that part of the tail contained large amounts of ionized material, which glowed under sunlight and made the object look more intense. The presence of plasma meant that the object interacted with solar wind, and this interaction helped shape the direction of the tail. Solar particles pushed the tail away while pockets of dust inside the coma continued to shift and thicken. These details created an object that looked alive in the sense that it changed shape constantly. As the jets grew stronger, the tail stretched into a clearer line that was easier to recognize even with small telescopes. Observers from different countries confirmed the same features across multiple nights, which helped confirm that the changes came from the object and not from camera artifacts. The rapid development of these features reminded many people that a newly heated comet-like body can transform quickly under strong solar influence. Each night brought new details, and the process made 3I Atlas one of the most closely followed objects of the month. The dramatic growth of the tail also made viewers wonder what would happen to the shape of the object once more images were shared online and more people tried to interpret them. The rapid spread of images after the discovery created a wave of confusion because many people shared photos without checking how they were made. A few stream recordings showed a faint fuzzy shape that matched early expectations, yet edited versions of those same frames later appeared online with sharper edges and unusual colors. These edited pictures gained attention because they looked striking and mysterious, and many viewers assumed they were real. Some users cropped the images, which removed important context such as surrounding stars or exposure details, and the missing information made the object look more structured than it actually was. In several cases, people reposted artwork based on early frames without labeling them clearly. Once these stylized versions began circulating, the original context was lost, and viewers started treating the artwork as real evidence. This created a chain reaction that spread across multiple platforms as more people tried to interpret what they thought they were seeing. The confusion grew even larger when another comet named K1 Atlas began to fragment during the same week. Many users saw the name Atlas and assumed the breaking pieces belonged to 3I Atlas. This mistake became widespread because both objects were active and their images appeared around the same time. K1 Atlas was undergoing a natural breakup caused by heat and low structural strength, which is common for fragile comets. However, people unfamiliar with comet naming systems believed that the same breakup was happening to the newly discovered interstellar object. This misunderstanding led to dramatic headlines claiming that 3I Atlas had split into several parts or had turned into separate bodies moving across the sky. Astronomers had to repeatedly clarify that the two objects were entirely different and were located in different regions of the sky. Even with these explanations, the corrected information spread much slower than the early exaggerations. The mix of edited images, mislabeled artwork, and incorrect assumptions demonstrated how easily a real discovery can be overshadowed by online noise. This also reminded researchers that early public interest often brings a flood of attention before accurate details can be confirmed. As the discussion grew more chaotic, scientists focused on collecting clearer data from professional instruments to separate fact from confusion. This effort became increasingly important because new observations were arriving from different angles within the solar system. Those observations would soon change how people understood the motion and the structure of 3I Atlas. The release of new data from Mars gave scientists a fresh perspective on 3I Atlas, and this change in viewpoint became one of the most important developments in the early days of the investigation. Soon after the object was detected, the European Space Agency reviewed images captured by the ExoMars Trace Gas Orbiter because the spacecraft had been observing the region of space where 3I Atlas was passing. The images were not sharp, and the object appeared as a small moving dot crossed by background noise, but the value of the data did not come from visual detail. It came from geometry. The orbiter looked at the object from a location completely different from Earth. And this new angle allowed researchers to measure the path of 3I Atlas with much higher precision. When the two sets of observations were combined, scientists discovered that the predicted trajectory could be refined by nearly an order of magnitude. This improvement showed that the object was following a smooth and predictable path through the solar system. The updated calculations revealed no sign of sudden changes in direction and no unusual force pulling the object away from its expected route. These results helped settle many of the early rumors about dramatic movements or hidden propulsion. The Mars data also helped explain why Earth-based images made the coma and tail look distorted during the first nights. Different viewing angles caused parts of the tail to appear compressed or stretched depending on where observers were located. This effect was especially strong because 3I Atlas was still reacting to rapid heating, and the jets of gas that formed the early tail did not yet point in stable directions. The readings from Mars confirmed that certain visual features were simply the result of perspective. The unfamiliar angle of sunlight hitting the jets created shadows and highlights that made the object look different in every image. This allowed scientists to distinguish between real physical changes and illusions created by the line of sight. The data also revealed that 3I Atlas maintained a steady rate of non-gravitational force, which is normal for comets that release gas into space. The value was small and did not suggest anything unusual. These findings supported the idea that the object behaved like a natural body adjusting to new heat levels. For many researchers, this confirmation came as a relief because it placed the focus back on scientific analysis instead of speculation. The combined view from Earth and Mars created a foundation that helped guide the next stage of observations. This growing network of information soon revealed a new influence on the object that many people had overlooked. And that influence came from the Sun itself. The days after the discovery showed that the Sun played a much larger role in shaping the appearance of 3I Atlas than many viewers realized. During this period, an active sunspot group named 4284 rotated across the solar surface and released several bursts of energy that affected space weather throughout the inner system. These bursts included strong flares that sent waves of charged particles into surrounding space, and those particles created disturbances that influenced every object in their path. As the particles moved outward, they affected the environment around 3I Atlas and changed the way the tail formed during the early nights of observation. The jets coming from the object were already reacting to heat, but the additional force from solar wind pushed them in shifting directions and made some of them appear bent or uneven. This interaction made the developing tail look different from one night to the next. Especially in long exposure images where faint details became exaggerated. Observers noticed that the tail sometimes looked thicker or more scattered, and these changes did not mean the object itself was unstable. Instead, they reflected the constant pressure of solar particles pushing against material released from the surface. The strength of the solar wind increased during the most active days of the sunspot cycle, and this added force sometimes made the tail appear brighter or more stretched than expected. Photographs taken during stronger bursts of solar activity captured sharp streaks of light that came from dust grains reacting to the charged environment. In other cases, the tail looked faint or broken because solar particles moved through the region and disrupted the glow that usually highlights comet-like structures. These effects were normal for bodies that produce plasma, yet many viewers unfamiliar with solar physics assumed the object was changing shape on its own. Researchers explained that the Sun often shapes comet behavior, especially during periods of increased activity. The constantly changing flow of particles can create temporary features that disappear as quickly as they form. This is why images that look dramatic or chaotic did not necessarily point to unusual properties within the object. The behavior of 3I Atlas became easier to understand when scientists compared the timing of each flare to the shape of the tail recorded that same night. Patterns began to appear, and those patterns helped confirm that much of the visual change came from the surrounding environment rather than from the object itself. The influence of the sun added a layer of complexity to every image, and understanding this interaction became essential for interpreting new data. With this foundation in place, the conversation soon shifted toward theories that tried to explain the deeper nature of the object and the meaning behind its unusual features. The growing number of images and measurements pushed the conversation far beyond the usual scientific explanations, and many people began to wonder if 3I Atlas carried properties that were not common in natural objects. Some viewers believed that the constant changes in brightness and the unusual direction of the early coma showed signs of control, as if the object reacted with intention rather than physics. This idea spread quickly online because new images appeared every day, and each one showed the object looking slightly different. Supporters of this theory pointed to the sharp jets that seemed to rise from the surface in organized directions, and they argued that such symmetry suggested more than random gas release. Other people discussed how the plasma around the object looked unusually strong compared to many comets observed in the past. They believed that this intense glow indicated a deeper and possibly intelligent source of energy within the body. These interpretations did not rely on scientific evidence, yet they grew louder as each dramatic photo circulated across social platforms. Meanwhile, researchers focused on the measurable behavior of 3I Atlas and did not see anything that supported the idea of deliberate motion. The path of the object remained smooth and followed the predictions made after the first calculations. No sudden acceleration appeared in the data, and no detectable change in direction suggested any kind of propulsion. The small non-gravitational forces recorded in the measurements matched the slow release of gas expected from a heated surface. Scientists explained that gas jets can sometimes align in ways that look patterned, especially when the body rotates while being heated by the sun. This rotation creates repeating surface behavior that may appear intentional in images, even though it comes from simple physics. Plasma intensity also varied because the solar wind changed strength throughout the week, and these fluctuations affected how brightly the tail and coma appeared in photographs. The glow grew stronger when solar particles were dense, and it faded when the environment calmed. These changes followed natural patterns that matched other comet-like bodies moving through the same region of space. Although many people enjoyed imagining advanced technology or unknown intelligence behind the object, researchers emphasized that the available data still pointed toward a natural origin. The unusual appearance came from its interstellar history, its exposure to sudden heat, and the active solar environment around it. The combination of these factors made 3I Atlas look unfamiliar, but unfamiliar shapes did not make it artificial. By the end of the first week, the discussion shifted toward what would happen next as the object continued to release more material while approaching a critical point in its journey. That next stage became the focus of observers who wanted to understand how it might behave when it moved even closer to the inner regions of the solar system. The days that followed showed that 3I Atlas was entering the most active part of its journey, and the material released from its surface became easier to observe as the object moved farther into the inner solar system. Astronomers noticed that the jets grew stronger as sunlight continued to heat the surface, and this heat pushed more dust and gas into surrounding space. The tail became longer and clearer in new images, and the brighter appearance suggested that the object was shedding a significant amount of interstellar material. This release created a long stream that stretched behind the object as it traveled, and the stream formed a path that scientists hope to study in the coming weeks. The dust moved outward with different speeds, and the lighter particles spread wider than the heavier ones. This behavior matched what researchers expected from an object reacting to strong solar energy. Scientists also paid attention to how close 3I Atlas was moving to the plane where many of the planets orbit. This region is filled with small pieces of dust from old comets, and objects passing through it often leave trails that can later cause meteor activity on nearby planets. Even though the object did not cross Earth's orbit, the material released along its path might eventually drift into regions that our planet passes through in future years. Researchers explained that this kind of long-term effect could create faint meteor streams over time. But it was too early to know whether the material from 3I Atlas would spread that far. The focus remained on the behavior of the object itself, especially because it was approaching the point where it would come closest to Earth. This stage did not pose any danger, but it offered a rare chance to record the structure of the tail with better clarity. Multiple observatories prepared to capture new frames during this period, and amateur astronomers around the world followed the updates closely. Another important event was the upcoming release of higher-resolution images from NASA. These images were expected to reveal the size of the nucleus with far more precision than any amateur camera could provide. The size of the core remained one of the biggest unknowns because the glowing coma covered almost all of its shape. If the nucleus turned out to be smaller than expected, it would match the behavior seen in other fast-moving objects. If it was larger, it could help explain why the object released so much material during the first week. Both possibilities would shape the direction of future research and help scientists understand the long journey that brought 3I Atlas into our system. With these final observations approaching, the stage was set for a clearer view of the object and a better understanding of what made it so unusual. This led naturally to the final reflections about what the discovery truly meant and where the story might go next. The first days after the discovery of 3I Atlas showed how quickly a distant object can capture global attention. Each new frame revealed changes in its jets, its glow, and its long stream of interstellar dust. The measurements from Earth and Mars confirmed that the object followed a stable path while reacting strongly to sunlight. Researchers focused on the physical behavior of the tail and the coma, and these details helped separate clear data from earlier confusion. NASA's upcoming release of high-resolution images promised a closer look at the nucleus hidden beneath the bright haze. This next update will close the early chapter of the story and open the way to whatever the object may reveal next. If you want to follow the next discovery, make sure to subscribe and stay with us for the updates ahead.